Right, let's get started with 6-2 right angle ratios. So just a reminder of all our possibilities. We've got the sine, the cosine, and tangent, and these three you learned about last year in geometry. And three new ones we're going to add in here, the cosecant, secant, and cotangent. So what are all of these things? We've got the sine of theta is b over c. Theta, any angle inside of a triangle less than 90. And so we've talked about opposite and adjacent, but really B and C, we're just picking sides. So anytime you see sine or cosine or tangent, we're talking about taking one side and dividing by another side, the ratio of sides. So sine or cosine or tangent are the ratio of sides. I think a little better are these. You're going to want to remember them like this. So you're going to say SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And then we did introduce our three new ones. So cosecant, always bringing up that. Anyway, cosecant is 1 over sine, the flip of sine. Secant is the flip of cosine, and cotangent, the flip of tangent. So we're going to need to become familiar with those. All right, let's try an example. For the given triangle, calculate sine, tangent, and cosecant. So we do need to know all the sides. So first things first, let's find our hypotenuse. And we would do that with the Pythagorean theorem, which you may be familiar already with a 3, 4, 5 right triangle. But if we do our calculations, we will get that h is the square root of 25, or 5. So that's our hypotenuse. And if we're at theta, remember that theta, if we draw our arc, will always touch the hypotenuse, which we have, and the adjacent. And then across from our angle, we will have our opposite side. Okay, so sine of theta is opposite over the hypotenuse. So the sine of theta is 4 over 5. What about tangent? Tan theta is opposite TOA over adjacent. So that's 4 over 3. And what about our cosecant? Well, cosecant is the flip of sine. Since we already know that sine is 4 over 5, then the cosecant is 5 over 4. All right, give it a shot to figure this out for cosine, secant, and cotangent. All right, we know the hypotenuse is 5 again, so the cosine is going to be adjacent over hypotenuse, which is going to be 3 over 5. So we now know the secant, because the secant of theta, I should put this in here, secant of theta, which is the flip of cosine, so hypotenuse over adjacent, is 5 over 3. And the cotangent of theta is, instead of opposite over adjacent, adjacent over opposite. So that's going to be 3 over 4. All right, let's try one more. Let's see if we can figure this out. Cosine, sine, cosine, tangent, and secant. So we have 7 rad 65. Let's go ahead and figure out our adjacent side here. This will be opposite. This is our hypotenuse, and this will be our adjacent side. So the square root of 65 squared is equal to 7 squared plus the adjacent side squared. So 65 equals 49 plus a squared. If I subtract here, I'm going to get 16. And so we know that a is going to be 4. All right, so cosine, the adjacent side over the hypotenuse, is going to be 4 over rad 65. We do need to rationalize our denominator. So we will have 4 rad 65 over 65 for cosine. Tangent theta, opposite over adjacent, so we will have 7 over 4. And secant is the flip of cosine, so hypotenuse over adjacent, we'll have rad 65 over 4. Try it for the remaining three trig functions. We have 4 for adjacent, 7 for the opposite, and rad 65 for the hypotenuse. Sine going to be opposite over the hypotenuse, which is 7 over rad 65. When we rationalize this, we're going to get 7 rad 65 over 65. And cosecant, the flip of that, would be rad 65 over 7. And then finally, the cotangent, adjacent over the opposite, is going to be 4 over 7. All right, now next thing to add in here are the cofunction identities. So what this is saying, 90 minus theta is always going to be your other corner of the triangle. So let's think about it like this. It might be easier if we thought about this with numbers. If I have 10 degrees, that's the angle I'm talking about. And I have my A, B, C for my sides. The sine of 10 degrees is going to be the opposite side, which is A, over the hypotenuse, which is C. Well, what happens if I walk across the triangle and now I'm standing at the 80-degree corner? And I say, okay, I want to talk about this corner, and I still want to be A over C. I want to keep that ratio. Well, now A is no longer the opposite side. Now A is the adjacent side, and C is still the hypotenuse. So we've moved to the other corner. Now we're dealing with cosine instead of sine. So if we switch to the opposite corner, we go from 10 to the 80, or if we went from the 30-degree corner, we would slide over to the 60-degree corner. Or if we were at the 40-degree corner, we would slide over to the 50-degree corner. Right? The two angles that are not the right angle always have to add up to 90 degrees. If we do that, we'll switch from sine to cosine. Or we'll switch from tangent to cotangent, or from secant to cosecant. Those are our cofunction identities. So let's see some examples here. So sine of 30 is going to turn into the cosine of the other corner of 60. The tangent of x will now become the cotangent of 90 degrees minus x. And for c, the cofunction of cosecant is secant. So we'll say secant, the other corner from 40 is going to be 50. What's the angle that adds up to 90? Give it a try, these two. All right, for A, you're going to say cosine of 45 turns into the sine of whatever 90 minus 45 is, and that turns into be 45. The cosine of 45 and sine of 45 are the same thing. For this one, we're going to switch to secant, and we're going to say 90 degrees minus y. All right, let's remember our special right triangles, 45, 45, 90, and 30, 60, 90. Let's evaluate the 6 trig functions for an angle that measures 30 degrees. So if we have 30 degrees over here, and there's our 90, remember we'll have x, rad 3x, and we'll have 2x. And let's make ourselves a little chart. Sine of 30, cosine of 30, tangent of 30. We'll start with those three. All right, so the sine of 30 is the opposite, x, over the hypotenuse, 2x, so that's going to be 1/2. The cosine is going to be the adjacent over the hypotenuse, so it's going to be rad 3 over 2. And the tangent is going to be the opposite over the adjacent. So that'll be 1 over rad 3, which turns into rad 3 over 3 when you rationalize it. All right, so let's find out the remaining 3. Cosecant is the flip of sine, and not theta. We know the angle. Cosecant of 30 degrees here is flip of 1 over 2 would be 2 over 1. The secant is the flip of rad 3 over 2, so 2 over rad 3, which turns into 2 rad 3 over 3. And then finally, the flip of tangent is cotangent. So the cotangent of 30 degrees is the flip of, and we can go right here, the flip of 1 over rad 3 is just rad 3. All right, your turn. See if you can do the same thing for the 60-degree angle. All right, so the 60-degree angle is across from the rad 3 side. It has the x side next to it, and it has 2x up here. And so sine of 60 degrees will be rad 3 over 2. And the cosine of 60 degrees will be 1/2. And notice that sine of 60 is the same as the cosine of 30, rad 3 over 2. Cosine 30, sine of 60. Cosine 60 sine of 30, 1/2. Those are the cofunctions. And then we have our tangent of 60. It's going to be our opposite over the hypotenuse. All right, let's flip them over. The cosecant of 60 is the flip of 2 rad, rad 3 over 2, which is 2 over rad 3. Rationalize your denominators. 2 rad 3 over 3. The secant of 60 degrees is going to be 2 over 1. And the cotangent of 60 is going to be the flip of rad 3 over 2. That's not right, is it? It's rad 3 over 1. So that's just rad 3. This will be 1 over rad 3. So that's rad 3 over 3. All right, so we can do the same thing for 45, or we can skip straight to our table here that we have here. So we did this in class to start the chapter. So here's our values. Let's remember how to get this from nothing. So this is the one we need to remember. The sine of 30 is 1/2. Okay, so as we go across here, if we're going to say for sine, the sine of 45 is rad 2 over 2, and for 60, it's rad 3 over 2. And then cosine is going to be the reverse. It's going to be 1/2 at the bottom, rad 2 over 2 in the middle, and coming up, we're going to have 2 over rad, we're going to have rad 3 over 2. Just flip the ends. All right, let's divide this. So tangent is sine divided by cosine, so this will be rad 3. This will be 1, and this is our 1 over rad 3, which is rad 3 over 3. And then we can finish this up for cotangent, secant, and cosecant by flipping this around as well. So we can take the rad 3 up here, and leave the 1 in the middle, and we can bring the rad 3 over 3 to the bottom. Secant is going to be this flip of, where are we? Secant is the flip of cosine, so 2 over rad 3, which is 2 rad 3 over 3. Cosecant is the flip of sine, so flip of 1/2 is 2. 2 over rad 2 is 2 rad 2 over 2, which is just rad 2. And cosecant will be the same exact thing. And then lastly, the flip of 2 over rad 3 from the top. I'm sorry, this is the flip of 1/2, so 2, and this one is the flip of 2 over rad 3. So we have our whole chart. All right, now if it's not one of those angles, if it's not a 30, a 45, or a 60, I expect you to put it in your calculator. So we just need to make sure that we're in radians. Let's go to our calculator, sine of 45, no, sine of 75, sorry. So let's make sure first we're gonna hit mode, and make sure here that degree is the one that's highlighted. So I am highlighted there. So I'm gonna come back up here, I'm gonna say sine of 75. And we get 0.97. Okay, so let's round to 2 decimals if it doesn't say. So the tangent of 67, we'll do the tangent of 67. Hit enter. And the secant of 52. Okay, we don't have a secant button here, but we know that secant is 1 divided by, secant is the flip of cosine, and we wanted 52. And then lastly, cosine of 30. And that is what rad 3 over 2 is equal to. So those are your values there. All right, so you can plug your answers in here and get those. Go ahead and plug those in. Pause the video, do those. I'll put the answers up in a second. All right, cosine of 22. You should have gotten 0.9272. Tangent of 81. We get 6.3138. The cosecant of 37. Cosecant is 1 over sine. And what was it? 37. So we would get 1.6616. And lastly, the sine of 45. 0.7071. Okay, that'll do it. We will see you in class.